So the first thing, like we said, is you have to identify the system and boundaries. Document actual system boundaries. Document system interactions and where those boundaries and the interactions intersect, where so that I understand how data is flowing throughout the system. All of this kind of stuff needs to be documented. And one of the best ways to do this in most cases is to use Unified Modeling Language or UML. This is something that developers in general are already accustomed to. This is something that at least the majority of security staff are aware of, and it's something that most networking folks and database administrators are also accustomed to, which means UML is something that most people can get behind. And one of the best parts about UML is there are additions to it, specifically the Object Constraint Language, OCL. OCL is phenomenal because it allows you to sit there and not only document how the system looks and how these boundaries are and the interactions, but I can actually give constraints. I can say, for example, that I have an authentication page, and that authentication page has these parameters. That's standard UML. But what I can also state is these parameters must have a length between this and this. And that's OCL. These parameters must be scanned in this way. This is how we're going to do our general input validation. I can have my whitelists contained now within the UML via OCL, so that when the developers are going through and writing their code, they actually know exactly how to validate this input. When someone is looking at the system, they can actually just look at the UML diagram and the corresponding OCL, and they can say, aha, so this thing should only allow inputs that look like this. Now they can verify against it. So now my test team has a single document that they can use to help them generate tests. The other really important thing is to understand that system is nebulous. And actually, we're going to kind of get to this in just a minute with the next step. But system being nebulous it's done on purpose. By using a nebulous term where it can be looked at many different levels, we're going to allow ourselves to examine this thing, whatever it is we're threat modeling, in different ways over time. Like we said before, maybe one time I'm looking at really hard how the back end operates. So how files and data happen to be transferred between each other. And maybe another time I'm looking at a more nebulous example and I'm using use case UML and other such things. And we have scenarios, user scenarios, and I'm looking at those and trying to determine how the system is going to behave based on that. When we talk about using our UML diagrams in threat modeling, we have different classes. So in general, it's great to use your deployment UMLs. It's great to use your class and package, object, component, and composite structure UML diagrams. All of those are nice and they're typically relatively high level documents, but they can also go deep. So they allow you a lot of latitude and how deep your threat modeling is going to go, how focused it's going to be, or how wide it's going to be. And that's one of the key things when we talk about scope is it's that depth and breadth, and you can't do both at the same time. And ultimately, we'd like to alternate between them. So maybe one threat model, it's wide, the next it's very narrow. We'd have a very narrow threat model looking at key or critical components of the system, where we store sensitive files, for example, or sensitive data. We'd have a very narrow threat model geared toward that. And where we have critical code, authentication and authorization, for example, you may have a very narrow threat modeling, but I may have a more broad threat modeling for the system in general as well. Sequence and activity UML diagrams are also phenomenal, and so are communication diagrams. I will tell you where a lot of people go wrong is they try to use state UML diagrams. State UML diagrams can be done successfully for a threat modeling exercise sometimes. But part of the problem is they tend to be way too much depth, way too much information, and they oftentimes are very hard to maintain. So my experience has been that's something I would try to stay away from, both for threat modeling, but also just in general. You may make a state diagram for something that absolutely positively needs it, but normally state diagrams are just too complicated, absolutely complicated. So they just don't lend themselves well to this. Once you've done the general UML diagrams, you can actually threat model using your timing and your use case and your interaction overview UML diagrams. Those are diagrams that are more detailed, but they're also generally very focused. They can lend themselves well to threat modeling, particularly with a team that's well versed in it, but it's probably not something that you want to use your first go around.